This is our last video for Chapter 10. We're at 10.9. We're going to talk about reasoning strategies and how to simplify a problem. We're going to be doing exponential square units. If you haven't seen the previous videos and you become lost or confused, you can just click on the description. But this video should stand by itself. So, sometimes the numbers in a problem are so large that it's difficult to get a direct solution. If we simplify the problem to an equivalent, easier one, it can help. And one way to simplify a problem is to find a solution using a smaller number. Then using a larger number, find another solution, and we can repeat this process gradually using larger numbers. When we have the solutions to simpler problems, organizing our information in a table often helps us find a pattern and a solution to our original problem. It's really important for our simpler problem to relate directly to the complex problem so that it makes sense. So, have you ever seen those puzzle books and it'll say, how many triangles are in this drawing? Well, how many possible squares can we find in this figure? Now, I know you can find each individual one. There's 6 going across and 6 going down. 6 times 6 is 36. But how many possible squares? We've got one big one, so that would be 37. We can make one here of these 4 squares. That's 38. We can do 3 by 3. That's, 39. We keep going and going. Now we can simplify the problem by asking ourselves how many squares are in a 1 by 1 square, then 2 by 2, then 3 by 3, and so on. Drawing a diagram like this, or making a table like I did here, and looking for a pattern, these strategies can help us find a solution. So, in one little square, we've got one square. It's 1 by 1. It's 1 unit by 1 unit. So that's 1 square total. When we have 2 across and 2 down for 2 by 2, we've got 4 squares. That's 4 squares total. If we were to add this one with this one, we would have 5 squares. Here's a 3 by 3. That's 9 squares inside of here. That's 9 squares total. If we add it with the 5, we'll have 14. And we can continue on. This one has 16. If we add it to the 14, we'll have 30. So I made a table. If the size of the original square is 1 by 1, we have 1 square. If it's 2 by 2, we can add that 1 with the 4 from the 2 by 2 and get a 5. When we add the 3 by 3, we're up to 14 squares. 4 by 4, now we're up to 30 squares, and so on. See? By the time we get to a 7 by 7 square, we can have 140 possible different squares that we could find inside of this figure. By organizing the data in a table, it helps us to show the pattern in the number of squares. For an original square with n individual squares, so we don't know how many it is. It could be 98, it could be 37, whatever. However many different individual squares are on its side, okay? There are 1 square plus 2 square plus 3 square plus 4 square plus 5 square, etc., plus n to the second power, n squared, see? And that's how many squares would be in the figure. So, in this 6 across and 6 down, we know there's 36 individual ones inside, but there's 91 possible squares in this figure. According to our table, when we get to the 6 by 6, there's 91 possible squares that we could find. Now, if you're still confused about what I'm talking about with possible squares, imagine it this way. We have one big large one that's going around the outer perimeter. Then we've got the 36 single possible squares that are on the inside. Then there's every possible 2 by 2 that we could find. There would be one here, then we can move it over one. There's another 2 by 2. We can move it over another one again and get another 2 by 2. We can move it over again and find another 2 by 2. Move it to the edge and find another 2 by 2. Then we can go down to this row and find 2 by 2 squares. And there's more. We could go down to the next row, and then the next row, and then the next row. So that would be every possible 2 by 2 square that we could find within this bigger square figure. Then we could find every possible 3 by 3 square. And this is just some of them. Then when we find every possible 4 by 4 and every possible 5 by 5, we end up with a total of 91 squares that we can find within this drawing. See? Isn't that amazing? So if you ever see a square like this and it's in a puzzle book and it says how many squares are here, if it's in units like this with the same amount going across and down, you'll be able to use this formula as a template to figure out how many squares are in the figure. Now take a look at this. We've got a square pyramid of sugar cubes, and we can easily find how many sugar cubes it took to make this square-based pyramid. We have 1 cube on the top, that would be the 1 square. Then there's 4 cubes on this second layer here. That's 2 squared. Then we've got 3 sugar cubes going across and 3 going this way. That's the 3 squared. And it goes all the way down to 6 sugar cubes at the bottom across and back this way. So we could add them all up and know it took 91 sugar cubes to make that square pyramid. Without taking it apart, we could just look at the sides of it and tell that it took 91 sugar cubes to make that. See? So, that's the reasoning strategy of simplifying the problem, and there's other reasoning strategies that we can use for word problems or any other problem that we come across, not just in life, not just in math, but in life. So we can write an equation, make an organized list, use logical reasoning. We could draw a diagram, make a table. We could simplify the problem just like we just did. We could even make a guess, test our guess, and then revise our guess if we're wrong. We can look for a pattern like we did with our table. We could even work backwards. If a problem is too difficult from the beginning to the end, we could try looking at the end and going backwards to undo it and see how they did it. Okay? So, enough about reasoning strategies. We're going to move on to chapter 11. We're going to start talking about polynomial functions. And we're going to talk about roots and zeros and how to tell if the roots and zeros are of an equation or a function. And the description will have the links to the 25 previous videos for chapter 10, where we talked about equations of second degree. And I hope this was kind of a fun video for you. It was a little bit off the track of what we normally talk about, but it's very informative and it'll help you solve some problems, all right? I hope you're having a great day. Keep your chin up. I'm proud of you, and I'll see you next video. Bye.